Hi students, welcome back to Learning Management System. Today we will discuss the second session of the third unit, that is brute force and exhaustive search of the subject design and analysis of algorithms. Myself Jagdish Mulge, lecturer in computer science and engineering branch. The course outcome of this unit is, after studying this third unit, you will be able to discuss various problems using brute force technique. In today's session, that is in second session, we will discuss in detail very popular algorithm, that is selection sort. So what is selection sort? Selection sort algorithm sorts an array by repeatedly finding the smallest element from unsorted part and putting it at the beginning. Right? That is, we divide a given sort in two parts, sorted array and unsorted array. So here you can see the given sorted array is divided in two parts. Left side part is sorted array and right side part is unsorted array. So what we do is we repeatedly find the smallest element in the given array and we put that smallest element in first half, that is sorted sub array, right? And next we find the second smallest element from the unsorted sub array and we put that into the sorted sub array until all the elements are sorted, right? Selection sort is a sorting technique on a given unsorted list or array. So in this algorithm, first we scan the entire list and we see the smallest element in the array and we swap the smallest element to the first position of the list. Similarly, scan the entire list and find the second smallest element and place in the second position in the list. So till how many times we have to do this repeated process till the array index or the passes reaches to n minus 1 position and elements of list are in non-decreasing order. That means in sorted manner, right? Let us see the algorithm. Name of the algorithm is selection sort. We are passing here an array whose size is n, that is from 0 to n minus 1. It sorts the given array by selection sort technique. Input is array and output is sorted in non-decreasing order. So here is the logic of the selection sort algorithm. So here we are using two for loops, which is, you can say, a nested for loop. We are using nested for loop. So outer for loop, we initialize I equal to 0 and repeat this up to n minus 1. For every iteration of I, we initialize the current index of the I or current value of the I as minimum, right? And next, in the inner for loop, we initialize j equal to current position of I plus 1, that is next position of the I value, j equal to I plus 1 to n minus 1. Next, compare j position value, that is A of j with A of minimum. If A of j is less than A of minimum, then initialize minimum as j position. Then swap A of I with A of minimum. So this is the logic of the algorithm. First, let us see the example how selection sort works. So here is an example whose values are 45, 68, 90, 29, 34, and 17. So according to the selection sort, what we have to do first? First, scan the list or the array. Take first position value as the minimum, current minimum. Then scan the remaining elements. As we are dividing the given array in two parts. First part is sorted array and second part is unsorted array. Find the smallest element in the array and swap that smallest element with the first position, what we initialize that to as minimum. Fine. So let us see the example. So this part we are taking as sorted array and this part we are taking as unsorted array. So as per the algorithm code or logic, so first position we are initializing it as minimum. Then scan the remaining elements, that is inner for loop, right? So you can see here the smallest element in the array is 17. First smallest element in the array is 17. Then what to do? Swap this. Swap the 17 with the current min, right? So let us go back to the algorithm to see the logic. Here, if A of j is less than A of min, then initialize min as j and swap A of I with A of min. So here min is what? Minimum value is 45, right? And the next smallest value is 17. Then swap 17 with the 45. So here we sorted 17. First smallest value we put in sorted subarray, right? And next scan the remaining array elements. So here now you can see the 29 is the second smallest element. Swap this 29 with the 68, right? So now the sorted subarray is 17 and 29, and once again scan the unsorted array elements. So here which is the smallest value, that is 34 is the smallest value or element. So you swap this 34 with the value 90, right? Then two subparts will be like this. Here sorted subarray and unsorted subarray. Next, remaining unsorted subarray, the smallest value is 45. Swap this 45 with 68. Hence, the sorted subarray values will be like this: 17, 29, 34, 45. And in unsorted subarray, once again scan the smallest element in this part. So here the smallest will be 68. Now swap the 68 with the 90, right? So here after successful sorting. By using the selection sort technique, the array elements will be this one, which are non-decreasing order. Okay, students. So for visualization purpose, let us see a small video how this selection sort works. Selection sort. So what is the logic here? Array is considered into two parts. Those are virtual subparts, unsorted and sorted array. Initially, whole array is unsorted. So step 1, select the lowest element in the remaining array and swapping part, selection part, swapping part. Bring it to the starting position. Then counter shift, that is index shifting. See here, this is sorted part and unsorted part. So first initially we are taking 64 as minimum and comparing with the next minimum value, right? So we are scanning the remaining array elements. Hence first phase or first iteration we find the smallest element in the array and we swap this and shift the index to the unsorted array. Once again find the smallest value in the unsorted array and swap that the second smallest element and shift the counter or index value, right? So like this the process goes on until all the elements are sorted. Are you getting, students, how this selection sort works? So here is a logic of the selection sort which already I explained in the above slides. Okay, students. Next, let us analyze the algorithm. So, for any algorithm analysis, what we have to consider in second unit, in detail, I explained you people what are the parameters to be considered for analyzing the algorithms. So, what we have to consider? We have to consider input size and the basic operation in the algorithm. So, what is the input size? Here, the input size is n. Size of the array will be the input size. And what is the basic operation? So in selection sort algorithm, the basic operation is comparison. For every pass, we are comparing the array elements, right? We are trying to search the smallest element in the unsorted part of the array, right? So from the logic, here we can see A of j is compared with A of min, right? So how many number of times that basic operation is being executed, that will be determining the running time complexity of the algorithm. So in the logic, you can see what is the control structure that is determining the basic operation, that how many times it is being executed. So here control structures are what? For loop, outer for loop and inner for loop, which we can say a nested for loop, right? So here we are using nested loop. So it depends again on number of for loops used. So we are using two for loops. One is outer for loop and second one is inner for loop. And the basic operation is executed within the inner for loop. So number of times outer loop is executed is, it will be the summation of I equal to 0 to n minus 1, and number of times inner loop execution will be the summation of j equal to I plus 1 to n minus 1. So here you observe it, we are initializing or starting the j starting from the current position of I plus 1, that is next position, right? So we are initializing j equal to I plus 1. So here it is a mathematical part of calculating the running time of a selection sort algorithm. So as I told you in the above slide, there will be two for loop we are using, I equal to 0 to n minus 1 and j equal to I plus 1 to n minus 1. After expanding this summation expression, finally we are getting the expression n square minus n minus 1 into n by 2. So which will become finally a quadratic equation. So if it is a quadratic equation, so we are going to take it as big O of n square. Okay students, so the time complexity of selection sort is big O of n square. Now let us see the advantages of selection sort. So selection sort algorithm is easy to implement and it can be used for small data sets. So ನಮ್ಮ algorithm input small data sets ಇತ್ತಂತಂದ್ರೆ ಅವಾಗ selection sort ಈಸಿಯಾಗಿ ಇಂಪ್ಲಿಮೆಂಟ್ ಮಾಡಬಹುದು. So what are the disadvantages of this algorithm? If you observe the running time of selection sort, it is a big O of n square. So in terms of algorithm's efficiency, we say it gives a poor efficiency. For what purpose we use big O notation? For worst case efficiency, we use big O notation. So here it is giving big O of n square. So selection sort is having a poor algorithm's efficiency. So if data size is large, so array size large ಇತ್ತಂತಂದ್ರೆ, for example array is having more than 100 elements, ಅವಾಗೆ selection sort algorithm consumes lot of time. ಯಾಕಂದ್ರೆ it is using nested for loop. In that case it consumes more time compared to other sorting algorithms. So if you compare this selection sort algorithm with insertion sort algorithm, then insertion sort algorithm is better than the selection sort algorithm. Understood students? So now let us see how to implement the selection sort algorithm. So I will show you how this selection sort can be implemented using the C language. Okay students, now let us see through the simulation. So here let me show you how to implement the selection sort using C language. So here I have used online C compiler, that is from online gdb.com. So here it is a In a list, languages are given, so I am selecting the C language. For that, I got include stdio.h and int main. So what all the data structures I needed to implement this selection sort algorithm? So I need one array. So let me take the size of the array b10 and one indexing point, two indexes, right, I and j. And in selection sort we have seen one minimum value, or you can say smallest value, and another value, say temporary value for swapping, or you can take instead of temp you can take swapping variable, right? We ask the user to enter the size of the array, enter the array size. Okay, students, right? So for taking the input from the user, we use scanf function, %d, ampersand of n, which is going to be array size. Then printf, enter array elements. Okay, students. So let me use for loop I equal to 0, I is less than n, minus 1, and I plus plus. Scanf %d ampersand a of I. Okay, students. So now let me write the logic of the algorithm. That is I equal to 0, I is less than n minus 1, I plus plus. Okay, students. Here is a small correction. So here assign min equal to I. So let me write the inner loop j equal to I plus 1, j is less than n minus 1, and j plus plus. Okay, students. So after this, what is the logic we have seen? Comparing the present j value with mean value, that is a of j, whether it is less than a of mean. If so, then assign min equal to j. Then swap the present value with the min. That is, if min is not equal to I, then swap it. That is, swap equal to a of I, and a of I equal to a of min, and a of min equal to swap. Okay, students. So after this, write the code for sorted array. So here is a code for printing the sorted array. Okay, students. So what we have written? We have written the code for selection sort algorithm. For that, we have taken one array, two indexes, one min variable, one swap variable, and we entered all the array elements. And here we use the selection sort logic, right? Here we initialize I equal to min, and we are comparing the present value of j with the min. If present value is lesser than the min, then what to do? Initialize min value as j and swap that value with the min, right? So let me run this program. So here it's a complete code. So now let me run this code. So once again you check the logic. So here we are using two for loops, outer for loop and inner for loop. Okay, students. So here we are swapping the elements. So let me run this C program for selection sort. So it is asking user to enter the array size. So let me enter the array size as 6. Next, what it is asking students? Enter array elements. So I am entering the array elements as say 50, 40, 23, 10, 100 and say 90. So I entered 6 elements 50, 40, 23, 10, 100, 20. What should be the expected output, students? So outputs should be sorted array, that is non-decreasing order of elements, that is from 10, 23, 40, 50, 90 and 100, right? So let us see the output. So sorted array. So here you can see the output is in a sorted manner: 10, 23, 40, 50, 90 and 100. As expected, we got the output. Understood, students, how selection sort works? Okay, I hope you understood the complete concept of selection sort algorithm, its working and its analysis, and selection sorts advantages and disadvantages. Okay, students. So here are some references for your kind information. Okay, students. Thank you for watching this video.